Same question, two setups. On the left, one agent reading sources one at a time. On the right, four agents, all working at once. Left is still reading, right is already done. Anthropic measured this exact architecture, beating a single agent by 90.2%. So why isn't everyone building it? Because of one detail almost nobody mentions. This is what one of those four agents actually receives. 4 words. It has no idea what it's researching. Let's make that concrete, because this is the part most explanations skip. Say you're deciding whether to adopt a new framework at work. You need the docs, the benchmarks, the open issues, and the alternatives. Hand all of that to one agent. It reads the docs, then the benchmarks, then the issues, one after another. 2 things go wrong. It's slow, because every source waits for the last one, and its context window fills up with raw pages. By the time it reasons about your decision, it's drowning in text it already read. Here's Anthropic's answer, and it's the whole idea. Quote, subagents facilitate compression by operating in parallel with their own context windows. Read that again. Compression. Each subagent burns its own context doing the reading. Each one hands back only what survived. 4 agents, 4 windows, 4 clean summaries. You're not just going faster, you're reasoning over 4 times the material without ever holding it. So the pattern is worth building, but there's a reason most first attempts fall apart. A coordinator is not a smarter agent, it's a router. It hands each subagent a context window that starts completely blank, and 3 decisions decide whether the whole thing works. How you split the work, what you tell each agent, how many you spawn. Get those wrong, and your system returns an answer that looks complete, but whole sections are missing, and nothing warns you. We're going to fix all 3, then build the thing end to end. And if you're sitting Anthropic's architect exam, this is Domain 1, Task 1.2. So how is this actually wired? Picture a newsroom. 1 editor, 4 reporters. The editor decides the angles, assigns a beat to each reporter, then builds the story from their copy. Reporters don't call each other. They file to the editor. That's hub and spoke. The coordinator is the hub. Every subagent is a spoke. And this is the rule that matters most. Subagents never communicate directly. All traffic flows through the coordinator. The coordinator owns 5 jobs. Analyze the request. Decompose it into non-overlapping subtasks. Delegate with explicit context. Aggregate what comes back. And evaluate. Did we actually cover the question? If not, it redelegates. That last one matters. Coverage checking is a loop, not a step. Anthropic calls this the orchestrator-worker pattern. A lead agent coordinates, and specialized subagents run in parallel. Most people hear multi-agent and picture a team chat, agents talking, debating, handing things off. That's not what this is. Try it. Say your benchmarks agent finds a memory regression. It changes what your issues agent should be looking for. There's no channel for that, no shared memory, no group thread. The only thing those 2 agents have in common is the coordinator that spawned them. So the right mental model isn't a team. It's a wheel. Spokes touch the hub. Spokes never touch each other. Anthropic's docs are blunt about it. Quote, each subagent runs in its own context window, with a custom system prompt, specific tool access, and independent permissions, and when it finishes, it returns only the summary. Now that sounds like a loss. It's the entire point. The subagent spends its context reading. You keep yours clean. Which brings us to the rule that breaks every first build. Before I show you the code, quick prediction. Your coordinator's system prompt says, research whether to adopt bun in production. Then you send a subagent the prompt, search for relevant articles. Guess what it searches for? Nothing useful, because it never saw the coordinator's prompt. Here's the analogy. A subagent is a contractor arriving on day 1, expert at the trade, 0 knowledge of your house. If you say fix it and walk away, you get a guess. Anthropic's docs say it directly. Each subagent starts with a fresh, isolated context window. It doesn't see your conversation history, or the skills you've already invoked, or the files Claude has already read. So the fix isn't a better model, it's a better prompt. Every subagent prompt carries 4 things: the full topic, the specific focus, the time frame, the output shape, explicit, every time, redundant across agents. That redundancy is the design. Enough theory. Let's actually build one. 3 functions, that's the entire system. Function 1, the subagent. It takes the research topic and one specific focus area. Look at what's in the prompt: the topic, the focus, the time frame, the output shape. Nothing is inherited, so nothing is assumed. It returns JSON because the coordinator has to read it later. Function 2, decomposition. The coordinator asks Claude to split the question into 4 distinct areas, and that word distinct is doing real work. Different angles, not 4 flavors of the same angle. We'll see exactly what happens when that line is missing. Function 3, the coordinator itself. Decompose. Delegate to a subagent per area. Collect the findings. Hand all of them to one synthesis call. Now look at the models. The subagents run on Haiku because they're doing retrieval, not reasoning. The coordinator runs on Opus because splitting the question well is the hard part. Cheap model for the width, smart model for the split. One more thing. In production, use structured outputs. Then that JSON parse can't fail. That's the whole system. Point it at a real decision and you get a sourced report. But right now it's still slow. Look closely at that list comprehension. It runs the subagents one at a time, which is the exact problem we started with. One change fixes it. Wrap each call and gather them. Now all 4 run at once. Anthropic's number for this change. Quote, cut research time by up to 90%. 90%. And here's the detail that catches people. The API call is blocking. So async on its own buys you nothing. You have to hand it to a thread. That's what _thread does. Miss that one line, and your parallel agents run in a very convincing straight line. Same output, same cost, none of the speed. Now the part the hype videos leave out. Anthropic's own numbers. Agents use about 4 times more tokens than a chat. Multi-agent systems use about 15 times more. 15. And here's what reframes the whole architecture. In their analysis, token usage alone explained 80% of the performance variance. Read that again. The multi-agent system isn't winning because the architecture is clever. It's winning because 4 context windows hold more than one. You're not buying intelligence, you're buying parallel context with money, which is completely fine when the answer is worth more than the tokens. A framework decision your team lives with for 2 years? Easily worth it. A definition you could have looked up in 10 seconds? Not even close. That's the trade. Now you can actually price it. So how many do you spawn? The wrong answer is the one most people ship. Run the whole pipeline every time. Question comes in. What is prompt chaining? Off goes the web search agent, the document analysis agent, the synthesis agent, the report generator. For a definition, that's a SWAT team fetching a coffee. Slow, expensive, and no more correct. Dynamic selection means the coordinator reads the query first, then picks. Simple factual question, 1 agent. Skip the pipeline. And Anthropic published actual numbers for this. Simple fact finding, 1 agent, 3 to 10 tool calls. Direct comparisons, 2 to 4 subagents, 10 to 15 calls each. Complex research, more than 10 subagents with clearly divided responsibilities. They learned that the hard way. Their early system spawned 50 subagents for simple queries and scoured the web for sources that didn't exist. Remember the 4 agents from the intro? For that question, 4 was right. For most questions, it isn't. Now the mistake that quietly ruins real systems, decomposition. Remember that word distinct back in the decompose function? Here's why it's there. Take a topic, AI in creative industries, split it into digital painting, graphic design, and photography. 3 agents, all parallel, all working perfectly. And the report comes back missing music, literature, and film entirely. That's not 3 angles on a topic. That's 3 photos of the same wall. I've done this. My first research agent split a market question into 4 subtopics. All 4 were the same segment. The output looked thorough. It covered a quarter of the question. And nothing in the pipeline catches it because every subagent succeeded. Anthropic's fix is a checklist. Every subagent task needs 4 things: an objective, an output format, guidance on which tools and sources to use, and clear task boundaries. Now, before you write any of that, you might not have to. If you use Claude Code, this architecture already ships with it. Make a folder, .claude/agents, drop in a markdown file, a name, a description, the tools it's allowed, the model, that's a subagent. Claude reads the description and delegates to it on its own, and it follows every rule in this video. Quote, Each subagent starts with a fresh, isolated context window. Same hub and spoke, same isolation, same summary coming back. You get the entire pattern for the price of a text file. So here's the honest advice. Try it there first. Write the API version when you need something nice. Claude Code won't give you custom retrieval, a scheduled run, your own aggregation logic. Most people never need to. So what do you actually point this at? The test is one question. Can the work be split into parts that don't need each other? If yes, it fits. Framework evaluations, docs, benchmarks, issues, alternatives, 4 agents, competitive research, 1 agent per competitor, codebase exploration, 1 agent per module, read-only, incident review, logs, metrics, recent deploys, all at once. Market or literature scans across different sectors. What doesn't fit? Anything where step 2 needs step 1's answer. Refactors, migrations, most writing. Here's the tell. If your subtasks keep wanting to talk to each other, you pick the wrong task. Split it differently, or use 1 agent. One more honest caveat. Anthropic is explicit about where this fails. These systems perform poorly where all agents need the same context, or where there are many dependencies between agents, which is why most coding tasks are a bad fit. Editing file 3 depends on what happened in file 1. That's a relay, not a race. And there's an operational cost nobody mentions. These runs are long and state accumulates. When something fails halfway, you can't just restart. Anthropic had to build resumption because starting over is expensive and frustrating. Their own words. LLMs are not yet great at coordinating and delegating to other agents in real time. Design for that. Don't design around it. So, 4 rules. Build it when the work is wide and the parts don't need each other. Give every subagent its own full context. Split across distinct angles, never subcategories of one. And try Claude Code subagents before you write a single line. Working through the Claude Certified Architect exam? This series maps Domain 1, lesson by lesson. Subscribe, and Lesson 1.3 is next. What does the coordinator do when a subagent comes back wrong?